Identify the core chemical concept tested. This question tests the application of Hess's law to Gibbs free energy, delta G degrees. Because Gibbs free energy is a thermodynamic state function, the overall free energy change of a multi-step process is independent of the pathway. Therefore, if a target chemical equation can be written as the sum of a series of individual reaction steps, the overall delta G degrees is simply the sum of the free energy changes of those steps. Analyze the target reaction and align reactants/products. Our goal is to manipulate the three given reactions so that they add up to the target overall reaction. 4NH3 plus 8O2 gives 4HNO3 plus 4H2O quad reactant alignment. In H3, the target reaction has 4NH3 on the reactant side. Reaction 1 also contains 4NH3 on the reactant side, so we keep reaction 1 exactly as written. Text reaction 1. 4NH3 plus 5O2 gives 4NO plus 6H2O quad delta G degrees 1 is equal to minus 1010 kilojoules per mole of reaction quad product alignment. HNO3, the target reaction, has 4HNO3 on the product side. Reaction 3 also contains 4HNO3 on the product side, so we keep reaction 3 exactly as written. Text reaction 3. For number 2 plus O2 plus 2H2O gives 4HNO3 quad delta G degrees 3 is equal to minus 170 kilojoules per mole of reaction quad. Align intermediate species for cancellation. NO and number 2, the intermediate species NO and number 2 do not appear in the target overall reaction. Thus, they must cancel out when the steps are added. To consume the 4NO produced in reaction 1 and supply the 4 number 2 required in reaction 3, we must manipulate reaction 2. Reaction 2 is written as text reaction 2. 2 number 2 gives 2NO plus O2 quad delta G degrees 2 is equal to 70 kilojoules per mole of reaction quad. We must reverse reaction 2 and multiply it by a factor of 2. Modified reaction 2. 4NO plus 2O2 gives 4 number 2 according to thermodynamic rules. When a reaction is reversed, the sign of delta G degrees is flipped. When it is multiplied by a coefficient, its delta G degrees is multiplied by that same factor. Delta G degrees modified 2 is equal to minus 2 times 70 kilojoules per mole of reaction equals minus 140 kilojoules per mole of reaction. Sum the equations to verify the target reaction. Add the three mathematical steps together. Begeneraral reaction 1 and 4NH3 plus 5O2 gives cancel 4NO plus 6H2O and delta G degrees 1 is equal to minus 1010 kilojoules per mole of reaction. Modified reaction 2 and cancel 4NO plus 2O2 gives cancel 4 number 2 and delta G degrees modified 2 is equal to minus 140 kilojoules per mole of reaction. Reaction 3 and cancel 4 number 2 plus O2 plus 2H2O gives 4HNO3 and delta G degrees 3 is equal to minus 170 kilojoules per mole of reaction. Line summed reaction. And 4NH3 plus 8O2 gives 4HNO3 plus 4H2O and end array. Note, the 2H2O on the reactant side cancels out, with 2 of the 6H2O on the product side to leave net 4H2O. The reactant O2 moles sum to 5 plus 2 plus 1 is equal to 8O2. Calculate the final free energy change, delta G degrees overall. Sum the individual free energy changes. Delta G degrees overall equals delta G degrees 1 plus delta G degrees modified 2 plus delta G degrees 3. Delta G degrees overall equals minus 1010 plus minus 140 plus minus 170 equals math. 1320 kilojoules per mole of reaction. This confirms option D is the correct answer. The correct answer is option D, minus 1320 kilojoules per mole of reaction.